Cool. Okay, so I just want to quickly have a little bit of a look at the topics in, this is our last lesson. So obviously we do as much as we can. We can't do every single thing, but it's nice to have a little bit of a look back. So the main tools that you have taken in, the distance formula, you've learned about the gradient formula, you've learned about the midpoint formula, you've learned about how to find the angle of inclination, and you've learned about the equation of a straight line. Now, all of these things can be applied to different types of problems. So the ones that, knowing whether or not parallel lines are parallel using the gradient, knowing whether or not lines are perpendicular, show that an angle is a right angle. Okay, so let's start with this question. We have ABC, we want to find D such that this is a parallelogram. Now, one of the things I want to know, what are some of the properties of a parallelogram? Can someone tell me what the properties of a parallelogram are? I think one that comes to mind is opposite sides are parallel. Now, what else does a parallelogram, other properties? The angles the diagonals bisect. I'm not sure if the angles bisect. I also know that opposite sides are equal. Opposite sides are equal. And then quite an important one is that diagonals cut each other in half. Or another way of saying that is they bisect each other. Now, for this first question, we don't need all those properties, but it's important to remember that parallelograms have these properties. Now, let me bring this back actually. So if we use the properties of a parallelogram to help us, we know that because the distance from B to C is equal, so this distance and this distance are equal, and this are parallel, the journey to go from here to here, the green journey, must be the same as the journey to go from A to D. So what I'm going to do is I'm going to get my GPS coordinates using the green route. So what I'm going to say is if I start at B and I want to go to C, how much does my X coordinate change? It looks like the X becomes bigger. How much does the X coordinate change to go from -2 to 5? Yeah, so we just go +7. Now, how much does the Y coordinate change to go from 0 to 3? So it goes from 0 up to 3. So I think I can just write Y + 3. Okay, so we've got the GPS coordinates. Now we're going to type them in. I mean, I'm using this like silly analogy, but basically I'm going to start at 0, 6, and I'm going to go on the same journey. So if I add 7 to my X and I add 3 to my Y, what point am I going to end up with? So I go add 7 to 0, and I should get 7, and add 3 to Y, and I should get 9. And so the missing point that I needed to figure out is going to be 7, 9. If I have a point D, which is 7, 9, I will have a parallelogram. The question has been asked by Masana, where did 0, 6 come from? 0, 6 is the point A over here, and it went on the blue journey to get to D, but it used the route that I got from the green journey. Okay, don't worry, we're going to do 3 of these. I'm going to explain again now. So I'm just going to leave this up on the board, and we're going to start the next type of question to go from there. Hi, Cass. Let's unmute Cass. She has a question. Maybe people can't. Okay, let's see if I can unmute you.
Hey, sir.
Hey.
So to find the coordinates, can we break down the midpoint formula?
Okay, you can use the midpoint formula, Cass. So The thing is, I think it takes longer. It's not wrong though. So what you could have done is you could have said, look, here is a diagonal, and I can find the midpoint of that diagonal. Okay. And then using the fact that I've got a common midpoint, I can hop from the -2, I can find that and use that to help me find D. But from experience, I do think this method is quicker. And so I'm going to prioritize this for tonight just because I think it saves students time. But you're not wrong. You can do it that way as well.
Okay, can you also use the distance formula? Will that work?
Whoa, you could, but it would be a simultaneous equation. And honestly, it would just take up so much time, it wouldn't be worth it. So you'll see tonight, I'm really going to teach you about techniques that are the most efficient, because in an exam situation, you want to save as much time as you can.
Okay, thank you.
Cool. Okay, everyone, I know a couple of you might have missed the explanation for the previous one, so I'll do this one again. And I want to, let me just bring this in. Determine the coordinates of H such that ABCH is the parallelogram. So first of all, where is H? Well, we have to keep the order. So ABC. If we don't keep the order, we wouldn't know where this H is going to go. Now, I don't know exactly where it is, but it's going to be somewhere on this side. If I had to put my H down here, I would be breaking the order that they gave me, and I have to keep that order. Okay, now, I have a choice. The method that I'm emphasizing is learn how to get, this is a parallelogram, and so I'm going to choose 2 points that give me the directions. So there's 2 combos, but I'm going to choose B, and I'm going to say, how do I get from B to A? I'll call that the blue route. So in order to go from B to A, I will figure out what happens to get there. Then I will start with the point C, which is down here, and I will apply the same route. So when I say by route, what do I mean? Well, how do I get from -2, which is the X value here, to 6, which is the X value there? What do I need to do? Yeah, I just need to add 8. Now, to go from 2 to 4, what do I need to do on the Y coordinate? Yeah, you just add 2. Okay, so you've got your directions. Now you're going to use your directions to get to from 6 to up to H. So you start with 6, and what were the directions? You needed to add 8. So work out what this point is, this point H. How did I get 8 asunder? What I said was basically I went 6 minus -2. So I looked at the, oh, wait, bring that back. I looked at the 6 here and the fact that it was -2 here, and I have to go 8 across to get in line with 6. Okay, so we'll get 6 plus 8, we'll get 14, and then we get, what have we got? We've got, oh, sorry, it's not 2, it's -2. Sorry, guys. If you look at the question, it's 6 minus 2, not 6, 2. So I'm at -2, and then I add 2. So I'm at -2 down here, add 2, and I get 0. And so H, the coordinate, is 14, 0, which if we actually do the scale more accurately, what this is saying is that there's 14. So it actually, and that looks more like a parallelogram as well. Okay, I'm going to go over the first step again, and then we'll practice this one more time before we move on. So if you look at the first step, I look at where H is. I need to get the directions to go from one side to the other. Then I use those directions to get from C to the point H. And the reason this works, okay, the only reason this works is opposite sides of a parallelogram are equal and opposite sides are parallel, which means that the journey has to be the same length and it has to be at the same angle. That's why this journey has to be identical to this journey. And that's what I'm making use of. Okay, Kayleen, so there's two ways of doing it. Instead of going from B to A, I could have also used another method. Like I could have gone from B, I could have gone from B to C and then gone from A to H, and you would have got the same answer. Yeah. Okay, let's do one more like this. And I'll really show you here. Okay, in this case, I haven't got the words, but I want to say, the question will say, find R such that PQRS is a parallelogram. So I want to ask, there's two choices. I can either start by saying, look, I want to go from P down to Q, and then using that information, I can go from S down to R. Or the other way of doing it is to say, what is the journey to go from P to S? And then whatever journey I get for that, I start at Q and I go to R. And what I do, I'm going to use the green route first. I write down the point X, Y. And then I say to myself, what do I have to do to get from -2 to 7? So what do we do to get from -2 to 7? Pop it in the chat. Yeah, we add 9. All good. What do we do to get from 3 to 5? Yeah, it looks to me it goes from 3 to 5. You can see it going up. So we get y plus 2. And let me keep it in green, otherwise it's going to get confusing. So y plus 2. Okay, I call this the directions. But now I'm going to use the directions because they have to be the same as the blue one. And I write down -3, 1. And I want to get to R, but I'm going to use the same directions. What is my point R going to be? So -3 plus 9 is 6, and 1 plus 2 is 3. And so this point will need to be 6, 3. That's it. So again, I'm going to move on now because it's just a method I wanted to show you, but I think it's very helpful in finding the missing point when you want a parallelogram. Don't worry, Naledi, if you go back and watch these three, if you go watch these examples again, it'll make a big difference and you will get there. Okay, I want to move on to a slightly different type of question. That's a little bit vague. Okay. I just want to grab something from my previous class because I think somehow left that one out. Let's go to here. Let's grab this question. Okay. I want to talk now about how do we prove something is a parallelogram. So there are 3 ways to prove something is a parallelogram. The one way of proving it is to use the distance formula. Kat, you would get full marks. Yes, you would definitely get full marks. Okay, so let's look at this question. This is different to the last one because they give us 4 points and they say, show this is a parallelogram. And there's 3 ways you can do it. The one way of doing it is to use the distance formula. The other way of doing it is to use the gradient formula. And the third way of doing it is to use the midpoint formula. Now, if you use the distance formula, you have to show that opposite sides are equal. And then it's a parallelogram because you have 2 pairs of opposite sides. If you want to use the gradient formula, you show that you have 2 pairs of opposite sides parallel. So 2 pairs opposite sides that are parallel. But The way that I like the most, the one that is the quickest, is to show that the diagonals of a parallelogram bisect each other, or they cut each other in half. And the way we do that is we use the midpoint formula. So if we can show that the diagonals bisect each other, we know it's a parallelogram. So how do we do that? What we do is we find the midpoint of each diagonal, and if the midpoint is common, if it's the same on both diagonals, that shows the diagonals bisect, and therefore ACR is a parallelogram. So to start with, I want you to find me the midpoint of AE, and I want you to find me the midpoint of RC. Go ahead and do that, and then we'll have a discussion further. Let's see what we would get here. So the midpoint for AE, 4 plus. And then we get 1, so half and 0. Okay, so how would we write this up? We would then just say ACER is a parallelogram, and the reason is the diagonals bisect. So it's not that you couldn't do it another way. You can do it another way, and it's equally correct. But I love how quick and efficient this is. Now, give me a thumbs up if you followed my logic for this. You feel okay with the idea. Maybe it's a bit new, but yeah. Now, sometimes, instead of asking us whether or not prove something's a parallelogram, they ask us to prove that something is a rhombus. And a rhombus is a more specialized parallelogram. It's got equal sides, and it's got diagonals that bisect at 90, etc. And so I'm pretty sure this isn't a rhombus, but I'm just going to show you, if I wanted to try and prove it is a rhombus, what would I need to do? Now, because a rhombus is just a parallelogram with something extra, we have to first check that it is a parallelogram. And so we've done that with the diagonals that bisect each other. If it's a rhombus, the diagonals bisect each other at 90 degrees. So we would need to show that these diagonals meet at 90 degrees. And I want to ask you, what's the easiest way to check whether or not diagonals are meeting at 90? What tool do you think would be the easiest tool to use? Maybe someone can come online and tell me, or if I want to check if two lines are hitting at 90, who thinks, okay, Azri and D-Leg, okay. So you're quite correct. You find the gradient of RC, and you'd find the gradient of AE. So just to check or not whether this is a rhombus, we didn't have to do this, but I'm using it as a learning opportunity. Find me the gradient of each of these, and then let's see what we find out.
Mr. Ace?
Yeah.
There's a question in the chat. If you could please explain those 3 points that you said there, how to prove a parallelogram.
Okay, I must have missed that. So if you want to prove something is a parallelogram, you have 3 choices. The one is to show that the opposite sides are equal, and that we would use the distance formula, right? So that would be like if I focused on that and that, and that side and that side. Now, That's the first method, using the distance formula. If you show that the yellow and green sides are parallel to each other, that would be the second method. And the one that I did actually looked at the diagonals and showed that there was a common midpoint on both diagonals. So those are the three methods I recommend, because I know that this one is the quickest from experience. I would use that unless it forced me to use something else. Okay, so now let's find those gradients. So RC is -1, -1. So wait, it's 1 minus -1. Look. 1 over -1 minus 2. So that gives me 2 over -3. And then AE is going to be 2 minus -2 and 4 minus -3, which gives me 4 over 7. So are these two lines perpendicular to each other? Okay. So RC is not parallel to AE, and so therefore it can't be a rhombus. Now, that's what I thought. I wasn't, the question didn't ask me to prove it's a rhombus, but I just wanted to show you the little bit of extra work we would need to do if the question did ask us to prove it's a rhombus. And I will have one like that after the break. I really am a big fan of diagonals, because I feel like diagonals, we work with the diagonals in these quadrilaterals. It's just so quick and efficient. And then it pays, it makes your whole system more efficient. Okay, we've worked hard for half an hour. Our brains need a break. So I want everyone to step away from their chairs, and I want you to join me in standing up for a second. And all I want to do is I want to give you 30 seconds to do whatever you want to do that relaxes you. So for me, I'm just going to swing my arms like this. Feel free to do the same. Do whatever just loosens your body up. Just make your body feel free. So like this. And then I like to sometimes do some circles, just to kind of feel my shoulders. And then I change direction. I start with small little circles, and then I go with big ones, just so my arms can feel. Right. And then maybe just shake out your body for a bit. Shake out your arms and shake out your legs. Okay, and then do a stretch that's helpful. I like doing the shoulder stretch like this, because I find when I'm looking over my computer, my shoulders tense up. Most people do when they're hunching forward. Let's do that. And then let's maybe do a tricep stretch. This is probably the best, the more. Like that. And then on the side. Oh, doesn't that feel good? And then just swing it out one more time. Okay, what we're going to do to get our heart rates up, to get the blood moving in our bodies, is we are going to do some jumping jacks. And we are going to do 10 of them. So make sure your surroundings are safe and clear, that you're not going to whack anyone when you get going now. And the way a jumping jack works is you go 1 and so on. So we'll start in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we are done. And I think we'll just have a little riddle thing to allow us to unwind a bit more. So we're going to go back to Maths 24 for today, just to not get too rusty on Maths 24. And here are your 2 cards. You have to make 24 using 4 numbers. Remember that the line is at the bottom, so that's a 6 in the red card, and it's a 9 and an 8 in the blue card. So you have to use all three. You have to use all three numbers. So Sonic, I think you are onto it there. So there might be other ways though, hey? So 5 times 6 minus 3 times 3, which is 30 minus 6, which is 24. There might be another way of doing it. Toboko agrees. And well, sure, your way, let's have a look. 5 times 3 is 15. And then you go plus 6 plus 3, which is also 24. Well done. Yeah, nice. What about the blue one? Can you guys do the blue one? Blue one's a little bit trickier. Maybe we'll save this for next time. I was thinking, what about if I got 8 minus 5, that would give me a 3. Would that be helpful? Not quite. This is a tricky one. Is this one we need to come back to? Who can crack the case here? Oh, I just saw it. My brain had a flash of inspiration. Must have had my 9 minus, okay, wait. So 5 times 4 is, where do the brackets go? 9 minus 4 is 5. So 9 minus 4 is 5. And then 5 times 4, this is what people, plus 8. I think that's still too big. Okay, I'll give you a hint. If you go 9 minus 8, you get 1. So if you go 9 minus 8, you get 1. How can that help you with the ones you've got left? You've taken 9 and you've taken 8. How do you use the remaining ones to get up to 24? Oh, here we go. I think Lomex has a good one that's better than my one. 8 minus 4 is 4. And then 4 times 5. Oh, but you still have to use the 9, hey? Lomex, that's the other problem. So I want to suggest, if I've used 9 and 8 to get 1, then can't I go 5 plus 1 is 6, and then 6 times 4 is 24. So 9 minus 5 is 4. 4 times 4 is 16. Oh, that works. Yes. Okay. You could have also done 9 minus 5 is 4, and then gone times 4, which is 16, and then add 8, and you get 24. So that's another way of doing it. Oh, that was a tasty one. That was one of the harder ones we've done recently. But I thought that was a good break, a good challenge for us. Well done, team. Okay, let's go back to what we were doing. And let me ask you to do this question here. This one says, show that ABCD is a rhombus. Now, in the last example, I gave you a clue how to do this. And there's 2 parts to it. I'll take questions from the class if you're unsure, but I'd like you to try and do it solo if you can. And yeah, ask a question if you're unsure, but So there's the two parts to proving something's a rhombus. There are other ways of doing it, but the quickest way that I can think of is to find the midpoints and then find the gradient of the diagonals and see what you find. Okay, so the first thing that looks promising is that the midpoints are, we have common midpoints, which is good for showing the diagonals cut each other in half. So we know it's a parallelogram. The question is whether it's a rhombus. Okay, so how would we find that? I just found the wrong one there. Wait, -3. So minus, oh, that should have been BD that I just worked out. Now what about AC, the gradient? And so what we know now, and we do have to make the statement, is that MAC times MBD equals -1. And because -1/2 times 2 is -1. And so what we know then is that BD is perpendicular to AC. So how do we finish this question off? What is to get full marks for it? So we should then say ABCD is a rhombus. And the reason it's a rhombus is that the diagonals bisect at 90 degrees. So, you know, the bisecting part, the fact that cut in half was handled here, at 90 degrees was handled here. And that's how we do it. Now, another way of doing it, if you really like the distance formula, what you could have done is you could have found it's a parallelogram, and then what you could have done is you could have worked out the length of two sides that are next to each other, or sometimes what we call adjacent sides. If adjacent sides are equal and it's a parallelogram, it's also going to be a rhombus. But again, I'm kind of erring on the side of teaching you the quickest method because I think that makes the most sense unless you have to use it. Okay, let's do another shape. And the next shape I'm going to want to try and prove is a rectangle. Now, staying with the theme of to prove something is a rectangle, I first show it is a parallelogram, and I think you all know how to do that, but you have to prove something a little extra. And we're going to focus again on the diagonals. Now, all we need to show, okay, is that it's a parallelogram. And in addition to that, we also need to show the diagonals are equal in length. Now, what tool do you think we're going to use to figure out whether or not the diagonals are equal in length? Who can tell me? Maybe someone can come online or someone can put it in the chat. Yeah, distance formula. Exactly. So to show that the diagonals are equal in length, we use the distance formula. So how are we going to prove this? The first thing you're going to find is you are going to find me midpoints to prove it's a parallelogram. And then you are going to find me the length of the diagonals. And then after we found that, we can make a comment about whether we think it's a rectangle. So go ahead and do that for me. And then we'll have a conversation once you've got your working out done. So midpoint AC, midpoint BD. And then you need to find me the length of AC and the length of BD. Over to you guys. I'm going to just grab some water while you are doing this. This is looking good. Seems like that has to be minus a half. Am I doing something wrong here? Because I'm getting different length diagonals. What is everyone else getting for their diagonals? So AC, 3 minus 4, 0 minus 5, so that's fine. And then DB, 2 minus 3 is 5, 7 minus 2 is 9. Aha. So everyone, if I if this is true, then it cannot be a rectangle because rectangles have equal diagonals. So let's wait for a few more students to join us, but 49 plus 25. Okay, yeah. So in this question, as it currently stands, yeah, so Patejo, what does that mean? Okay. This means this is not a rectangle, but it is a parallelogram, okay? Which I suppose you can kind of see it because rectangles, now that I look at it, rectangles have 90-degree corners. And so in that sense, we could have also checked for that, but we know that rectangles have equal, they always have equal length diagonals. So once we've checked those diagonals, it can't be a rectangle. So you would just say ABCD is not a rectangle, diagonals not equal length. So A, B, C, D, not rectangle, diagonals, I'll make a little bracket here, diagonals not equal. And if you had to classify it, you would classify it as a parallelogram. Okay. I wonder if we have time for, should we do one more? Let's do one more, and then we'll call it a day for tonight. I think we can do one more. Okay, these are all, you can see these are taken straight from old exam questions. So you're at that level. So here is, yeah, we might run out of time for this, but let's just see how we do here. Because that last 4-mark question, we might run out of time. But you do 2.2.1, 2.2.2, and then we'll have a crack at 2.2.3 to finish. Okay, so we do see that AC is perpendicular to BD, so that's 2.2.1. Now we're going to do 2.2.2. Now to prove that AC bisects this one, I think you know what we're going to do, don't we? So what have we got for BD? And so what we would say is that AC bisects BD. And how do we know? Well, we've got common midpoints. Let me just do that. So how, in this question, it's specifically saying prove they bisect. How do you know? Well, they have common midpoints. And we should find that the common midpoints are 1, 4. Okay. So at this point, what do we know for sure? We know that this is at least a rhombus, but it could be a more specialized, if you look at the shape, it's definitely a rhombus, but maybe it's a rectangle or a square. And so what I want to check is in order to know what's really going on here is if these diagonals are equal in length, or I could either check that. So maybe some of us should check the length of the diagonals, and maybe some of you could check if the rhombus, it's definitely going to have equal sides. So a rhombus automatically has equal sides, so that's not in doubt. What's in doubt is whether or not this is a 90-degree angle, or whether or not these diagonals are equal in length. How much time do we have left? Okay, guys, we have actually run out of time. So let me just explain what I would do. If this is if these diagonals are equal in length, all right, it essentially has to be a square, okay? Because a rectangle doesn't have diagonals that cut each other at 90. A rectangle, the moment it's a rhombus, it can't be a rectangle. So all I would need to check is if the diagonals are equal in length. In a square, if you think about a square, the diagonals are always equal in length. And so what I would do in the remaining time is I would check the distance of each diagonal. If they're equal in length, it's a square. If they're not equal in length, it would be a rhombus. I suspect they are going to be equal because it's worth 4 marks. And so what are you getting your 4 marks for unless you are doing that? Okay. But we have run out of time for today, and I think we've had a great session, so I'm not going to push it too hard now. Yes, it can be a square and a rhombus, but a square is a more specific shape. Yeah. Ongani has confirmed the diagonals are equal in length, in which case it has to be a square.